In this optimization problem, we're finding the point on a line that's closest to a given point. The first step in solving this problem is to read through our problem carefully, figure out what information we're given, and what we want to find. Our problem states that we want to find the point on the line, and that line is 6x plus y is equal to 9. That is closest to the point minus 3, 1. For step 2, we are going to fill out all 4 of these categories with all the information that we've been given from the problem. I went ahead and drew our point. This point is the point minus 3, 1. And then I drew our line, which is 6x plus y is equal to 9. We want to find a point on the line, and that's our red point here. So we're going to just label this xy. That's the point that we need to find, and it's the point that is closest to the point minus 3, 1. Let's go ahead and identify our variables. So we're going to say that x comma y is our point on the line. It's always good to write that down in words. Now what we're going to do is write down the equation that relates x and y. And that's actually the equation that we already wrote down, and it's the equation for our line, 6x plus y is equal to 9. And we'll come back to that in a minute. Let's now go to our next category and find out if we want to find a maximum or a minimum. We want to find the point on the line that is closest to the point minus 3, 1. So that means we have a distance, and I'm going to label this little d right here, between these 2 points, and that's what we actually want to minimize. So let's highlight min, and let's write down that we want to minimize d. Let me write down just the general equation for the distance between 2 points. It's the square root of y minus y1 squared plus x minus x1 squared. Now let's go ahead and let's substitute that x1 is minus 3 and y1 is 1. So this is the square root of y minus 1 quantity squared plus x plus 3 quantity squared. Now I'm going to show you a trick. I don't know if it's really a trick, but it's the easiest way to do this problem. If you want to minimize a distance, you can instead minimize a distance squared. And that's what we're going to do. We instead are going to minimize d squared, and we're going to call it capital D, and it is y minus 1 squared plus x plus 3 squared. The reason we're doing this is we're going to have to take a derivative of this function, and by getting rid of the square root, the derivative is so much easier. Now what we want to do is we want to substitute in for y, and we're going to go back to our equation for our line and use that to find y. So let's write down that y is equal to 9 minus 6x. So let's plug this in. Capital D is 9 minus 6x minus 1 quantity squared plus x plus 3 squared. This gives us 9 minus 1 is 8, so we have 8 minus 6x squared plus x plus 3 squared. The other piece of information that we need to fill in for this problem is the domain, but I'm going to hold off doing that until after we complete step 3. Now we're all set to go on to step 3. I'm going to highlight this because we're going to need that. Our third step is to find the critical values of our function capital D, so we need to take the derivative and set it equal to 0. I'm going to go ahead and recopy what we have. D is 8 minus 6x squared plus x plus 3 squared. We could have multiplied that out and found the derivative, but I think it's just as easy to do it this way. We're going to take the derivative, And we're going to need the power rule and the chain rule. So this is 2 times 8 minus 6x times the derivative of what's inside, which is minus 6, plus 2 times x plus 3. Now let's go ahead and multiply everything out. We have minus 12 times 8 minus 6x. I'm going to do that in 2 steps. Plus 2x plus 6. This gives us a minus 96 plus 72x plus 2x plus 6. And this leaves us with 74x minus 90. And I'm going to highlight that because we're going to need that in a few minutes. Now we can find the critical value. We're going to set this equal to 0. And this is going to give us that x is equal to 90 divided by 74. And we can divide both of those by 2. So we get that x is equal to 45 divided by 37. And let's highlight that. Now let's go ahead and let's find y, because we eventually want to find the point on the line. So we're going to need y. Y, let's see, we need to look back up here. Y is 9 minus 6x. So this is 9 minus 6. Oh, this is complicated. 45 over 37. Let's see here. We're going to multiply 9 by 37. And that is going to be 333. And then we subtract off 6 times 45, which is 270. And all of this gets divided by 37. So this gives us that y is equal to 63 over 37. Now what we need to do is find our minimum distance. So let's first find capital D. Capital D is 8 minus 6 times our x, which was 45 over 37. And that gets squared, plus x, which is 45 divided by 37 plus 3 quantity squared. I am not going to take time in this video to work through that calculation, but you end up with 676 all divided by 37. So that tells us that our distance little d is the square root of 676 divided by 37. And this gives us that d is 26 divided by the square root of 37. Let's go ahead and let's highlight that. That is our minimum distance. Now, it may feel that we're done, but we are not. We need to justify that this distance is a minimum. Let's go back up and fill in our domain. If we go back up to our problem, we have no constraints given on x. So that means that x can be anything. So we're going to say that minus infinity is less than x is less than infinity, and this is an open interval. So for our justification, we can use the first derivative test or the second derivative test. Our first derivative is highlighted up here in blue. It's really simple, so we definitely want to use the second derivative test. And I'm going to go ahead and write the first derivative. D prime is 74x minus 90. So D double prime is 74. That is greater than 0. This means that our function is concave up, and we have a minimum value. So let's write down that we have a min at x is equal to 45 over 37. And this tells us that our distance, little d, is equal to 26 over the square root of 37 is a minimum. And we'll highlight that. Now we are almost done. We just have to write down our final answer. To do that, we need to go back up and reread our problem and then clearly state our final answer in a sentence. We need to find the point on the line that is closest to the point -3, 1. So for part 5, we're going to write down that the closest point is 45 divided by 37, 63 divided by 37. And that's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.